Okay, some of you have already alluded to opening to page 711. That would be chapter 22, where we do begin the organic component for this chapter. As some of you have already been discussing amongst yourselves, this week begins on the last couple days of April, so that leaves 1, 2, 3 weeks, 3 full weeks of school would be the 17th of May, and then the following 21st and 22nd would be your final. Okay, so yes, we're counting down pretty quick. That leaves what, 17 days? Okay, now some of this that you see up here may look familiar from 2 years ago. Yes? No? Okay. And with that, one of the things that we had mentioned last week was until finals is here, the calculators can be put away because you don't need them. So what is the major difference between that of inorganic chemistry with what you see up on the board with just very, very basic information on what organic chemistry is? What do you suppose is the difference? Yes, in other words, it's the small neighborhood of where you would find elements 6, 7, and 8, okay? And with that, along with element number 1, and there's also some sulfur and phosphorus, nitrogen are also parts of that of organic chemistry as well, and then there's some halogen derivatives as well. Okay, so on the far right hand column, or as I'm looking at you, your left, far left hand side, okay, what do you notice that each and every one of them have in common? Yep, they all have the same suffix, which is an organic family, okay, which some of you may have been paging through around page 711 where this chapter begins. And there's different ways of writing these. For the most part, we just stick to structural formulas rather than that of molecular formulas. It doesn't mean you can't use them, but you're going to be more accurate, in my opinion, when you deal with a structural formula rather than a molecular one. So, that being said, from physical science, which you learned 2 years ago, that wasn't what I was going to ask. Okay? Yeah, there is a specific order, but there's one that is left out. Which one is missing? Because if you count them, there's only 9 up there. Okay? Because there should be 10 of them, and there's only 9. So, with that, I want to be able to pick a color here that you're going to be able to see, and I think this would be fine. Do you just want to work from the top down, or would you like to start with the simplest and work up to the largest? That doesn't answer anything. Okay, so the smallest one is what? Repeat that again. Methane. 1 carbon. How many hydrogens? Okay, what column is carbon in? It's in the 4th column. So therefore, it wants to make how many bonds then? 4. Okay? So if we really turn back the clocks to not only just, this is probably in physical science as well, column 4, those are the 4 valence electrons for carbon, correct? So we want to satisfy the octet rule. So where are these other 4 bonds going to come from when it refers to you don't need to be writing this part. If you are, fine. If not, yeah. So this is what you had learned in physical science and probably a little bit in chemistry this year. Okay, that is the dot diagram for that of methane. Okay, so when we look at this, you don't need to write all the hydrogens on around that. Okay, the reason for that is, what is sulfuric acid? What's the formula for that? Is that wrong? But would you write sulfuric acid like that? No, you wouldn't. Why not? What looks strange about it if you're saying no? Okay, so if that's the case, which I'm making an inference that you think that is more correct, which it probably is. So it's not that this is wrong. Why not write it like this? Yeah, redundant, and it's just understood that you have one sulfur atom, so you don't have to write the number 1 there. There will be times with some of these organic compounds you do have to write the number 1, but in this case, you correctly said you would not write it like this. It's just understood that you have one sulfur atom, so that's why that is the correct formula for sulfuric acid. So it's just understood that if you just put these dashes in here, that these elements around the carbon are what? Hydrogens. Okay? So, CH4. Okay? What is next? Okay? So, molecular formula, or excuse me, structural formula, that, and then the molecular type. I'm kind of running out of space. I'm glad I got them different colors. I don't know if you'll be able to see that on the video if you choose to watch it. But I kind of maybe should have left them out of there. We can come back to what's written in green. That's not all that important right now. We'll write them down again later. Okay, what's next? C2H6. Propane. Okay, so this will be the last one that I'll write the structural formula for. Okay, then the molecular formula, C3H what? And what type of pattern do you see emerging from here with the carbons? It's increasing by numbers of 1, but the hydrogens are increasing by numbers of what? Okay, and there will be a reason for that here. We'll explain that. Okay, after propane. Okay, so again, I'm not going to write the structural formula, just the molecular one. So C4H what? Now, if you're not writing these down, that's fine. Some of you probably either remember this from physical science or can just look at this and probably already know what it is we're dealing with. But if you're writing it down, that's fine as well. Okay, after butane. After pentane. And then, as you had said, this one is the one that is missing, heptane. And that's how many carbons then? How many hydrogens? Okay, after heptane. So C8, H18. After heptane is C9, H what? And finally, decane, C10, H22. Okay, so that is your order, yes? Methane, ethane, propane, butane, and then after you make the number butane and move up to pentane, what is significant when you look at the prefix? I know it means 5, and even to 6. pentane from physical science, what do we know? Pentane, hexane, heptane, octane, nonane, decane. Those are all prefixes of a geometrical what? Geometrical shape. So once you've made it past butane, one way to look at this is, where is the Department of Defense located? Not just Washington, D.C., but where is it located in the U.S.? Where? In the Pentagon. Right. Do we have a Pentagon close by to, not for defense purposes, but do we have a Pentagon close to us? Yeah, where is it? Okay, and the major tenant to that is which basketball team? Oh, maybe we don't. No, the Skyforce. Okay, so when we say major tenant, they're the ones that probably spend the most time there, although that might change. Maybe Augustana will be playing game. I don't know. I can't say that for certainty, but that is quite possible. Okay, so the major idea is, when you looked at octane, if you draw an octagon, we know that it is 8 sides. So from 5 through 10, it's the name of the geometrical shape that it would form. So how much of this is ringing a bell from physical science? Or is it all of it is? For the most part. Okay? So one of the things that I would think that we had talked about as well is, let's say, these are inorganic compounds. What elements are those? I heard lead, iron, and tin. Well, none of them really have the same letters that are in the actual English name, but those aren't English abbreviations. Does anyone remember what they're derived from? It's Latin terms, which I wouldn't expect you to know, but you had said that this is lead. Now, you don't need to be writing this down. This is iron. Of course, this is tin. But when you look at the Latin terms, Pb is plumbum, Fe is ferrous, I think, F-E-R-O-U-S, I believe, and then stannate. Okay? So these are the words in Latin, and this is the English translation then. So that's how these got their abbreviations. They're derived from Latin terms to make English terms. So derivatives then, like what we see on the far, your right side now, okay, these are called derivatives. Okay? And what that means, their names are derived from the alkanes that they would possibly be called. So what does methyl resemble? Methane. But methane, we know, has a formula of CH what? Okay, so if this was methane, we would call it methane. But we don't call it methane, we call it a methyl group. Do we remember what a methyl group was by chance? No. Okay, so someone pick a number between 4 and 8. Okay, so we will go with 6. Okay, so now pick a number between 2 and 5. Okay, now say left or right. So we said pick a number between 2 and 5, and then we said pick left or right. So you had picked 2 and right. So what we would see is this. Okay? What is the formula for that written in orange? Sure. Okay. Do you rest of you agree? Okay. So only in orange. How many carbons are there? 3 carbons. Where are they? 1 carbon. How many hydrogens are on there? Orange only. Okay? So what that means then, a methyl group has a formula of CH3. Because if that was CH4, we would call it methane. Okay. It's coming back. Okay. So this in blue, remember we said, unless you write something else, these are all hydrogens. You would agree that this is something else other than hydrogen, right? So this is not a carbon to hydrogen bond. This is a carbon to carbon bond. Okay? So when we name these, the first thing you're going to want to do is, if you have this open, and part of this we're just basing on prior knowledge. So alkane nomenclature on page 721. It's in that khaki or brown box or whatever you want to call it on the top. It says, number 1, name the parent hydrocarbon. Find the longest continuous chain of carbon atoms that have straight chain branches. Add the suffix "ane" to the prefix corresponding to the number of carbon atoms in the chain. Now, some people learn by just reading and understanding the rules. Other people maybe understand by just looking at the example. So with what we read in that first step, did we lose anybody? Because some people rather, like, I want to see the information in front of me. Does anyone feel confused right now? Okay. So then 2 says add the names of the alkyl groups in step 2. Add the names of the alkyl groups in front of the name of the parent hydrocarbon in alphabetical order. When there is more than one branch of the same alkyl group present, attach the appropriate numerical prefix to the name di for 2, tri for 3, tetra for 4, and so on. Do so after the names have been put in alphabetical order. Okay, so what we are saying so far, our longest continuous chain in step 1 is how many? Okay, so what is the prefix now for 6? Okay, so now, since these are all single bonded, what type of organic family is this? It's an these are all what? Alkanes. So here's our name, hexane. Is there anything branching off of that hexane? Yes, there is. There is a what group? a methyl group on which carbon? We want to think golf. So do we go with the lowest number or the highest number? Okay, so if we go left to right, 1, 2, 3, 4, 5, that gives us 5. But if we go right to left, 1, 2, 4, 5, 6. So on the second one, that's why we said, okay, we want to put a methyl group on there. So we had said pick a number. We said 2 through 5. We said 2. Then we said left or right. Then you said right. Okay? So with that, we've got a methyl group off of the second carbon. Naming this compound so far. Are we a little sketchy or maybe a little foggy, or this is good, let's keep going? But, okay, so left outside, are we on the bus? Left middle, right middle, right outside. Okay? So, what would happen, according to step 2, if we had done something like this? Okay, what does it say? How many methyl groups are on there now? Okay, so what prefix means 2 as far as derivatives? Di. We just read that in the rules, said di. Okay, now where are those methyl groups located? So now we would go 2, 3 dash dimethylhexane. Okay, and what about if we would do this? Now we've got 3 methyl groups on there, and they are on which carbons? 2 and 3, but we want to write 2, 2, 3, not dimethyl anymore, trimethyl. Okay? Because as it said in step 2, okay, it said when there is more than one branch of the same alkyl group, which these are, okay, present, attach the appropriate numerical prefix to the name. Di equals 2, tri equals 3. Okay? So, let's throw a different compound up there. Perhaps something like, do this. Okay, so according to your rules, find the longest continuous chain. Okay, the longest continuous chain is what? 8. So what's the prefix for 8? Oct. Okay. Okay. They're all single bonded. So that means that an alkane, an alkyne, or an alkene. It's an alkane. Is there anything branching off of that alkane? Yes. Something with the formula of not C2H6, because remember, this is a carbon-to-carbon bond, not a carbon to hydrogen. So, something with the formula of C2H5 is called an ethyl group. Surprise, surprise, what's a propyl group going to be called? C3H7. Okay, we won't go into isopropyl yet, but those are not all the derivatives that, yes. Oh, okay. Okay, what would happen if we put a 6 here? Yeah, C2H6. Okay, so ethyl is derived from the term ethane. But if we had another hydrogen, we'd call it ethane, but we don't. It's 5 of them. So one less hydrogen makes it a derivative rather than an alkane. That's all we're saying there. That's it. Okay? So what would we do if we had 8 hydrogens here? It'd be propane, but it's not 8 hydrogens, it's only 7. So therefore it's a derivative of propane. That's what we call a propyl group. Eventually, what will happen, these have to be placed into, maybe that's in step 3. Nope, it's in step 2. Add the names of the alkyl groups in the front of the name of the parent hydrocarbon in alphabetical order. So if you had all 3 of these, which one is going to come first alphabetically? Then this one, then this one. It doesn't matter that this might have a bigger number. It's still going to come first. Okay? Because they have to be in alphabetical order. That's in Rule 2. No, just the derivatives here. Derivatives are placed in alphabetical order. Yes. Okay, good question. So now, rather than have an ethyl octane, we would have, so we said think golf, right? Okay, so would we say 2-methyl 3-ethyl octane? No, it would not. You would not name it that. Why not? Because it's not in alphabetical order. We said it doesn't matter numerically even if this one's smaller. It doesn't come first. You have to put them in alphabetical order. That left outside, we good? Left middle, right middle, right outside. Okay? Yes. Okay, commas separate numbers, dashes separate numbers from words. No, no comma here. Does that answer your question? Okay. And no comma there. Okay. Now, we're just basing this presumption that, okay, some of this is from prior knowledge, which it is, okay, but we're going a little faster than you would in physical science, because you would agree, correct, that, okay, it's 2 years later. Yes, no, okay. Then when we get to the organic side for that as seniors, okay? Remember, in physical science, you just had two derivatives, okay? Just these two, okay? Then, as juniors, we add two more to it, propyl and isopropyl. No. No. Okay? So, then, for anyone who takes organic chemistry next year, there are four more derivatives added to them besides these. You'd have a butyl group, an isobutyl group, a tertiary butyl group, and a secondary butyl group. Okay? So it just, my point is, it gets to be a little more complex with every step that you take. And I think that's, not that it makes it right, but I think you would agree that we're a little more advanced than what we were 2 years ago, correct? Okay. Can we erase this? It's up on the board. All right. We didn't say anything. Nope. Not yet. Because I was afraid if we kept on going, we might lose some people. Okay. So back to those formulas that we had up there. Notice it was, the first one was CnH to the 2n plus 2. Okay, so go ahead and pick a number between 1 and 10. Okay, so we're putting 5 in for n. Okay, so if we put 5 in for that n, how many hydrogens do we have? What's that the formula for? Pentane. Okay. Okay. So one of the things that we also talked about when you were freshmen, okay, this eraser is, you could say it's a sponge. You could technically use this to clean things up. Okay. So it's dry right now, and you set this into someone spills a lot of water on the floor. So you set this right in the middle of that water. What is this eraser going to do? No. It's going to start to soak up as much moisture, water, whatever you want to call it, as it can until this sponge becomes totally what? Totally saturated. It can no longer hold any more hydrogens. Okay? This is a saturated hydrocarbon. It can't hold any more hydrogens. Okay? So if something is not saturated, we call it what? Unsaturated. Okay? So if we have something called CnH to the 2n, okay? We can't say 1, we can say 2, so we'll go ahead and pick a number between 2 and 10. Okay? So, if we put 3 in for n, how many hydrogens will that be? Okay? Now, this is unsaturated now because this is no longer an alkane. It's an alkene now. And the way that we can tell that, okay, there's a double bond in there. Okay? Okay, so left or right? Okay, so we now have our 3 carbons in there. So now we got to put our 3 hydrogens in there, or excuse me, 6 hydrogens. So you want to start on the left side and work right. Okay, so this carbon has 1 bond to that one. How many hydrogens can we put on there? Okay. This is a double bond, that's a single bond. Because this is now an alkene. Okay? Yeah, if it's all single bonds, these are all alkanes. We'll make that point here in just a moment. Okay? So, we got 3 down, 3 to go, right? Okay? Now, this carbon has a double bond with this one and one with this carbon. So there's 3. How many hydrogens can it hold? Just 1. Because we establish how many bonds can carbon have. You can only have 4. Okay? So, this carbon is double bonded to this one for 2. So how many more hydrogens can it hold? You can put them top and bottom or in that fashion too. Either one's correct. So how many dashes are on there? Just like what we pointed out. Okay. Alkene. So with this, so if this was C3H8, we would call it what? Propane. But it's C3H6, the prefix is still the same. Propene. There's an alkyne. We won't go into that yet today. Now, one of the things the author does is they start talking about isomers right away. Should we do that? No? Well, if it's right away, shouldn't we start talking about that? Oh. What's that? I don't think so. The freshmen have been working on isomers. Just like you did, it's no different. You've done the same thing. Okay? There's nothing up on this board that we have not talked about as freshmen. It's just one of those things. It might take a little bit of time to remember this. Okay? How many, is anyone overwhelmed out there? Okay? Okay, so yes, we can continue with this tomorrow. But again, the author starts talking about alkenes right away as well. We're trying to take this in a nice, slow, progressive pattern. Does anyone, because these derivatives are also found on page 719. It tells you what they are and where they come from. Okay, we'll pick up with this tomorrow.